Kumar B, working on an assistant professor in Department of ISE. Welcome to the design analysis of laboratory. Okay, subject code is 17CSL47. So today I'll be explaining you the program 6, that is a dynamic programming and 3D method. You're going to solve the knapsack problem. Now what do you mean by a knapsack problem? That I'll be explaining in a program.
Yes, good morning. So welcome to the knapsack, solving the knapsack problem using the greedy technique. So it's a Java program. Okay, so here again similar to that of a knapsack DB, here we have import java.util.scanner, okay, which is similar to that of your header files, where all the supporting files, all the supporting methods will be present in java.util.star. Okay, so here we have created a class K object, okay, followed by float W, that is the weight, profit and the remaining capacity of the knapsack. Next, the public class knapsack gr. So the class name should be same as that of the what you have specified while entering in the Eclipse. Okay, again the maximum of 20 objects followed by the number of objects and the capacity of the knapsack. Next, your public static void main. Okay, you're going to declare a scanner object where new scanner.n. Okay, so here you're going to enter the number of object. So n equals scanner.int, where the number of objects, say 4, 5 will be entered. Okay, and then you're going to create an array of object. Okay, so say for an example, enter 1 object, 2 object, 3 object, 4 object. Okay, so for reading that, here you have a read object. Then for calculating the optimal solution, you have you have a knapsack obj, and next is scanner.close. Okay, so for reading the object, it helps in the getting the inputs. Okay, as here you can see, a temp is of type K object, that is you're going to create an object which is of type temp. Next, similarly to that, a scanner. Okay, enter the maximum capacity. M contains a maximum capacity, and each of the objects weight will be entered, each of the objects profit will be entered. Then the remaining capacity of the knapsack will be calculated based on the P by W, where this is very important concept in terms of a greedy. Okay, next what you're going to do, based on the P by W ratio, you're going to find out the P by W ratio of each and every object, and based on that, okay, and based on that PW ratio, you're going to arrange it in a descending order, and based on which value, which project and which weight value, you're going to get a maximum. Okay, that you're going to consider first, followed by second max, third max, fourth max, like that. Okay, so initially you're going to arrange it. So how you are going to calculate? So 2 for loops, n minus 1, n minus 1 minus I. Okay, if object of j dot remaining capacity, if it is less, then what you are going to do? You are going to swap the two objects. Now what is this r? This r is nothing but, okay, the p by value of, say, object of 1 of p, object of 1 of w, object of 2 of p, object of 2 of w. Okay, so after swapping, here we have a static void knapsack. Okay, so here the value, here there's a considering of a fractions also. So here I've considered a float of x, next float of total profit, int of I, and it's a place value. So where you're going, it acts as a temporary object that holds the capacity of the knapsack. So initially the total profit will be 0. So for I equals 0, I less than I plus plus, initially the value will be 0. Next, if the weight of the particular object, if it is greater than the capacity of the knapsack, then you're going to eliminate that particular object, else you're going to calculate the profit. Now what will be the total profit? That x of I equals 1, in the sense you're going to consider that particular object, and total profit equals total profit plus that particular object profit. will be a total profit, and U is nothing but an M, that is the capacity of the knapsack, that you are going to, from the capacity of the knapsack, you are going to subtract. What you are going to do? You are going to subtract. What you are going to subtract? The object value which you have considered, that is the weight. Okay, similarly you are going to consider that, and if I is less, if the I value is less than n, if there are some more elements, okay, you need to consider the fraction also. So for that, x of I equals U by K of object dot I dot W. Then the total profit, okay, then the total profit, that is the remaining capacity of the profit, will be the fraction part of that particular object, okay, plus total profit, and then you are going to print the value, okay, and then you are going to print the total profit. Now let's debug. Oh, sorry, Knapsack 3D.